There are a few data types in Python that are called containers. Containers are objects that hold an arbitrary number of other objects. There are 4 built-in containers in Python: sets, dictionaries, lists, and tuples. And today we're going to talk about the dictionary data type. A dictionary is a mapping of key-value pairs. For example, if we consider animals and their classifications, we could talk about a frog, which is an amphibian, a parrot, which is a bird, a mouse, which is a mammal, and a crow, which is also a bird. So these are keys, and these are values. And a dictionary is a lot like a function in math in that the keys have to be unique. We can never repeat a key. But the value, as you see, we can have 2 birds in this dictionary. We can have 2 different keys that refer to the same value. And we use dictionaries as a way to store information about the different keys that can later be looked up by using the key. In this case, I'm using strings as keys, but keys could also be integers or floats, or quite a number of other objects. Not every object can be a key for a dictionary, and we'll talk about that later when we get to mutable and immutable objects. But for now, let's see how we can create and use our dictionary of animal classifications. There are a number of ways to create dictionaries, but we're going to use curly braces. We'll decide on a variable name and use the assignment operator with an open curly brace. And inside the curly braces, we'll define each of the key value pairs. For example, we said that a frog is an amphibian, and that a parrot is a bird, and so on. We'll add a couple more. To use the dictionary, we look up values using the keys. So if I want to know the value of the key frog, in other words, what classification is a frog, I can say print animal classes, that's the name of our dictionary, and the key I want to use is frog. I want to look up the value of frog. Let's add our infrastructure here and run the program. And there we go. So we asked our dictionary to tell us the classification associated with frog. The dictionary found the key value pair for the key frog and found that the value was amphibian. Similarly, we can look up cat and we get the result mammal. If we try to use a key that's not in the dictionary, of course, we get an error. This error is a key error, and we could catch it using a try block. Of course, we know that a dog is a mammal, and we might like to add it to our dictionary. We've already set up the dictionary, so how do we add another key value pair after the dictionary is already established? Well, it's almost the same as doing a lookup. We'll type animal classes and use the key inside the square brackets, but this time we'll use the assignment operator and assign the value mammal to the key dog. And we'll try again. Now the dictionary is able to use the key dog to look up the classification of dog, which is mammal. Incidentally, you might notice that PyCharm has underlined my whole dictionary creation, and it suggests that it could be rewritten as a dictionary literal. If I accept the suggestion, it simply reorganizes my assignment. There's no difference to Python because remember that Python allows us to split a line inside a grouping symbol like the curly braces. You can create your dictionary either way. I actually prefer having the key value pairs on separate lines. I think it's easier to read. I'm going to suppress this warning. Once a key value entry has been created, we can alter it. So suppose we made a mistake and said that dog was a bird. If we run this program, it dutifully tells us that a dog is a bird. We can fix that later by reassigning the key dog to the value mammal, in exactly the same way we made the original key value pair. So before the reassignment, dog pulled up the value bird. After reassignment, dog correctly pulls up mammal. We can also delete a key entirely by using the delete keyword with the name of the dictionary and the key. Running one more time. We first had the incorrect value. After reassignment, we get the correct value. And after deletion, the key is no longer found. Okay, too much hard coding here. Let's allow the user to look up items. We'll create a while loop. And we'll use this trick to loop forever. True is always true. Let's ask the user to name an animal. And instead of looking up a classification using a string literal, we'll use the variable animal instead. Let's add a little context. This won't get the grammar right every time, but let's give it a try. Please name an animal. I'll choose finch. So after I press enter, the variable animal will refer to the string finch, and it tells me a finch is a bird. I can ask about a cat, which is a mammal. A mouse is a mammal. Remember, we didn't define dog in our original dictionary, so I ask for a dog, and it says sorry, not found. Let's give our user a way to quit. Do you remember the word we used to break out of a loop? Instead of using the try except pattern, we can use a keyword called in with an if block. In will check if a particular keyword is a key in the given dictionary. Of course, we won't use except, but we'll use else if the keyword is not found in the dictionary. Let's try this. Works great. If we place the dictionary inside a print statement, we get a representation of the key value pairs in the dictionary. Later, we'll see how we can loop through these.